Alright, so we're going to be moving on to the 22nd problem in the grind 75. This one is called diameter of binary tree. We're given 30 minutes this time, so let's start the countdown now. Okay, so given the root of a binary tree, determine the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. And we want to return the length of the longest path between any two nodes. So we just have to output the length, so it'll be an integer. We don't have to actually output the path. So 3 is the length of the path 4, 2, 1, 3, or 5, 2, 1, 3. Okay. We have 1 and 2, then that's that. Okay, we're given a tree node class, left, right, and val. We won't have to create any new tree nodes. We are going to have to keep track of, I guess, what step we are on. This is interesting. So we can't just increment the count of the level, can we? I want to come up with a slightly more in-depth example. We're going to switch over to the drawing board. So let's put paint up top. Let's switch over really quick. So, okay, we're going to create our own binary tree. Say we have 7 up here. We have, what would I put down here? 3. And then I would put 11. This is usually the binary tree I like to make. 1, 5, 0, 2. It's going to be 4, 6. And let me actually push this branch over here a little bit. So we're going to push 11 out to over here. 11 is going to go down by 2, so we're going to have 9 here. And we're going to have 13 here. This is going to go down by 1, so 8, 10, 12, and 14. So this is a list that's between 0 and 14. Came out a little oddly shaped, but we're just going to roll with it. So basically the longest path is, let's see, do splits really matter, or is it just like, okay, so if say it's like 0 and 14, we go 1, 2, 3, 4, 5, 6, but say it's 0 and 10, you go 1, 2, 3, 4, 5, 6. So, basically, when we're at the root and we go down the left side and we hit a leaf, the next point, so if this is the start point and this is the end point, the point that will generate the longest path will have to be at the same level and on the other side of the tree. So it has to be, down this right path. So if we just get, what if we get like the depth down the left side, the depth down left, and then the depth down right, and then we just add them together. This is 1, 2, 3, and then we're just going to, add these together, I guess. So, is that good enough? I believe it might be, so let's see. If either, let's say, 0 side of 1. Okay. I think that might actually work. We just need to create a height function that will count the number of levels that we go down. So we just have to get the greatest between, left and right. So we're going to switch over to the LeetCode window now. So we need a height function. I'll make that some private thing. Maybe we can put it down here. Private function height. Is it going to return anything? Yes. It's going to return an integer. It is going to take a tree node, which we can just call root. Hold on. Okay, so let's say we just had to get the height of a normal tree. How do we do that? So we are given the root, and we want to get the, we want to go down to the leaf that is the farthest away from the root. So maybe we can take in an integer called count, and we can say if we want to get the height, int height is equal to math.max roots, we recurse down height, we do root.right, and then we're going to do count plus 1. This should be inside of that call. And then this, so that's our main recursive call right here. However, if we get to the point where, say root is equal to null, that we need a base case, right? So if root is equal to null, then we should return count. Right? Yeah. Okay. And then from there, we should just be able to return height. Let me see really quick. Okay, I believe that should be about it for that. Am I not accounting for something? So return count, revise height. So let's just kind of go through this tree. So say we return, we're going to pass in the root. We're going to initialize the count to 0. We're going to take the maximum of height down the left side or the right side. We're going to increment count. So count's going to be 1 here. And it's not null. So then we can go down here. Count will be 2. Then we're going to go down here. That's going to be null, so then we can return our current count. Okay, yeah, that seems to work. This will eventually, if we're looking at that left recursive call, this will recurse back the value 2. This one will recurse back the value 1. And just for my sake, I'm going to put the recursive call on the right subtree, just on the right. Okay, and then, yep, gonna return the height. And yeah, basically what we're going to do in the main function is call this on the left and the right. Let's just look at our constraints. The number of nodes in the tree is 1, so we'll at least have a root. So yeah, if we just have a root, then our longest path will be 0. Okay, so we can say, what are we going to say? We're going to call this function twice. So say, let's say int left height is equal to height. We're going to pass in root dot left and a count of 0. And right height is equal to height. I'm going to pass in root dot right and a count of 0. And then we are going to return the sum of left height and right height if my idea is correct about this problem. So diameter, longest path between any two nodes. Again, in this example, that would be 4, 2, 1, 3. So let's see, that's height of 1, 2, height of 1. So yeah, I mean, that seems to work to me. I feel like this might be a little too simple and there's something I'm missing. But I will just submit, first run the test to make sure there's no syntactical issues. Okay, that worked. So let's look for the entire thing. Okay, so we did get some error here. Output was 7, expected 8. So there's definitely some sort of case that we are not accounting for. So this is quite a long input. I'm going to copy this. We're going to throw it here in test case, and then I'm going to draw it. We still have some time left, so let's see. I'm actually going to erase everything that we had on the drawing board, just set up a new canvas. Okay, and then we're just going to go back and forth writing out this tree, and I believe it goes in level order. So let me switch over to the paint view. Okay, and I'm just going to mechanically write out this example. So 4, -7, -3, that's 4, actually, let's get our favorite color. 4, let's put this way out here, this way out here, -7, -3, then null null, -9, -3, that's going to be null null, -9, -3. And from there, 9, -7, -4, that's going to be 9, -7, -4. Okay, I already see where the issue is, but -7, -4. And null, and then 6, null, -6, -6. be 6, null, -6, -6, then null, null, and then 0, 6, 5. That's going to be 0. I think here 6, 5. This is a much better example. I'm not going to draw out the rest, but let's see. As we can see, the longest path does not appear to be simply just take the height of the left and the height of the right and get the sum. So we have like 1, 2, 3, 4, 5, 6, but we can also do, here we can do 1, 2, 3, 4, 5. Maybe this one just goes off like forever. So this would actually be the diameter of the tree. So, I mean, all we really have to do is recurse, I guess. Let's see. I'm going to have this base case right here. If root is equal to null, then we're simply going to return 0. And we can do math.max. Can math.max take multiple values? I'm assuming it can. So we can say left.right plus height, or a recursive call down the left and recursive call down the right. So let me say diameter. Did I switch over? Let me switch over to the LeetCode window. So basically, I'm keeping everything we had before. It's just I'm going to take the maximum value going down each subtree. Because if we look back at the paint, the illustration, I mean, if we just cut out this right here, it's really the same idea. We're just treating this one as the root, and then we're getting, the maximum diameter with that. So that's why we just need to recurse on the tree all the way down, and then we should have a base case here as well. So yeah, that should be just fine, actually. Binary tree, and we'll go root dot left, and we'll do the same thing. Do root dot right. Is that off the screen? Let's see. A little bit off the screen. I'll just put a space right here. I'm pretty sure math.max can take in multiple arguments. I really hope it can, actually. I guess we'll find out. So just going to make sure there's no syntactical issues. Is not a valid type of tree node. Invalid test case. Oh, that's my fault. Just going to take that away. Run the default test case. Okay, let's see. No suitable method found. So I guess you can't take the maximum of multiple values like that. Math.max. So I mean, I guess we can just take math.max twice, which there must be a better way to do it, but what would be the proper way to do it? The current level? Um, I'll make an int called max sub tree diameter, and that's just going to be equal to math.max. It's going to be equal to this, but we're just going to take out this right here. And then we're going to return again the math.max, this time with between left plus right and max sub diam. Okay, so let's run the test case really quick. Left, oh, it's left height and right height. Okay, let's submit. All right, so that succeeded. So yeah, that was not too bad actually. I guess I learned something new about math.max. I'm sure this is pretty much what the solution is too. We'll see if there's anything else that we can shave off of this implementation. Yeah, but that's been the attempt.